So welcome back to the fifth and final installment of this series of 5 ways to solve a circuit. We've solved it 4 ways already. We built the thing, we then used Kirchhoff's method, we then used superposition, and finally Thevenin's approach. And this final one we're going to use as a last resort. We're going to simulate the circuit. It can be the case that the circuit is just too difficult to solve analytically. Now we've solved a circuit in this series that we can do with pen and paper, but sometimes the circuits are too complicated and we have to make approximations and we want to see how well it works. So for that approach we're going to try to simulate it. So what we're going to do here is bring up a circuit simulation package. It's based off of SPICE, which itself is based off of Kirchhoff's equations. There's a number of them out there. I use one called Multisim, so let's load that up. You can sign up for an account. I've already done that, so we're just going to go in here. And we can make our circuit that we've been simulating here and directly get the currents and voltages. So let's create a new circuit. We have our dashboard here. Again, we're in multisim.com. And we're just going to simulate our circuit that we've created so far. So we're going to need to plop a few resistors, right? So we got one here, and it was a 2 kilo ohm resistor. So we'll put that in there. And we're just going to duplicate it. We'll do it a bunch of times. We're going to make a couple copies. And again, whoops, we'll just throw it wherever. And we had a few battery sources. Or voltage sources rather. We had a few batteries. So let's find that here. I can't really, it's been a while. Here we go, DC source. And this one I believe was 9 volts. So let's plug that in there. 9 volts. And let's copy it and put another one here. We're going to make sure it's pointing the right way. And that's going to be 6 volts. So we got a 6 volt source now. Okay, so we got our 6 volt source, our 9 volt source, and that was mostly our circuit. We need to wire things up. So if we just drag or click once on these, whoops, empty points here, it's not liking that. Maybe it will now. Maybe it got very cross with me then when I tried to connect a voltage to a voltage. There we go. Now it's okay with it. Relax, Multisim. All right. So we're going to plug these guys in. And quick and easy, we have our circuit. Now I happen to also know that it becomes very upset with me if I don't tell it what 0 volts is. Remember that all voltage is relative, so I'm just going to give it a ground. Now there's nothing fundamental about that ground. It's just going to be the reference point for all of our sources here. So we've made our very simple circuit and I can run it. And it's running. Now we don't really know anything yet because we haven't probed it. Probing it is like sticking a multimeter at different points in the circuit. So let's look what the voltage is at R2 as compared to ground. That should have been 5 volts. So we'll run that. And here we go. Oh, it already told me it was 5 volts. That's great. I wonder if I can do this live. Can I move this live? Nah, I have to stop the simulation. Let's put here, what was it? I believe it was -1, if I remember that far back. Sweet, we get -1. And the other one, I think, was -4 volts here. We can put multiple probes, by the way, so let's do that. Let's just put them all up at the same time. What do you think I'm going to get if I put the voltage here, down at the bottom? Any guesses? Well, if you guess 0, you'd guess right, because that is all tied to ground, and everything is measured with respect to that point. So what do we have here? -4 volts, 5 volts, -1 volt, and 0 volts. Almost done. We can also find, let's get rid of this. Things are getting kind of messy here. Get rid of a few of these. We can also find the currents. So let's see if we can get a current probe in here. I'm going to make a little bit more room. See if I can drag this down so we can actually put current probes in there. And instead of measuring voltage, I'm going to measure current. Out of date. Run it again. Oh, I don't think I actually put it on there. All right, let's stop it and run it. Oh wait, there we are. Now something else is happening. There we go. We have a current meter now. So we run it, and we have, what do we get? 2.5 milliamps. Exactly what we found. Great. And we can probe the other points. I think we can do both. We can look at voltage and current. So let's do voltage and current right here and see what it says. And we'll do the same this way on the other one. Voltage and current here. And see what we get. What do we get? -4, -2 milliamps, 2.5 milliamps, and -500 microamps, or half a milliamp. Now what about these negative signs? Remember, half a milliamp going down on this right resistor here is the same as, or rather, negative half a milliamps going down is the same as plus half a milliamp going up. Similarly here, we have current running up, plus 2 milliamps running up through this resistor, and we have all the currents adding up to 2.5 milliamps in the middle. And that's really all there is to simulating a circuit. A bit later in the course, we'll talk about how to simulate more complicated things, such as filters and time-dependent circuits. In fact, that's one of your labs. So that's it, and that's it for this series, 5 ways to solve a circuit. There's no one way to do it a lot of the time. You just pick the easiest one and go from there. All right, thanks for watching.